Okay, well, this is the City of Marshall Stormwater Pollution Prevention Program 2015 annual public meeting. My name is Jason Anderson. I'm the Assistant City Engineer for the City of Marshall. Just some background about the program. The City of Marshall is designated as a regulated small municipal separate storm sewer system, or an MS4, under the National Pollutant Discharge Elimination Systems Phase 2 regulations, or NPDES Phase 2 regulations. The NPDES Phase 2 program is a federally mandated program established by the EPA. The Phase 2 program was developed in 1999 as part of the 1972 Clean Water Act. At the state level, the Minnesota Pollution Control Agency, or MPCA, has implemented the NPDES permit program to cities with a population of more than 5,000 people. The Redwood and Minnesota rivers, the rivers that the City of Marshall's stormwater ultimately discharges to, are listed as impaired waters by the MPCA and EPA. The impaired status mandates the MPCA establish load limits for each permitted city. The primary goal of the permit is to restore and maintain the chemical, physical, and biological integrity of the waters of the state through management and treatment of urban stormwater runoff. This is accomplished by management of MS4s through a Stormwater Prevention Program, or SWPP or SWPP. The Minnesota Stormwater Manual identifies urban pollutant sources as those associated with vehicular traffic, lawn and garden care, fallout from air pollution, municipal maintenance activities, commercial and industrial activities, illicit discharges, improper disposal of household hazardous waste, pet and wildlife, fecal waste, litter, construction activities, combined storm sewer and sanitary sewer overflows, and runoff from driveways and parking areas. The City of Marshall submitted its NPDES permit and stormwater pollution prevention program in February of 2007. The permit requires the city to develop, implement, and enforce a stormwater management program. The SWPP must be designed to reduce the discharge of pollutants from MS4s to the maximum extent practicable. The city must reduce its phosphorus output from stormwater by 30% when the SWPP is fully implemented. Phosphorus contributes to algae blooms, which in turn cause dissolved oxygen depletion in waters downstream. The dissolved oxygen depletion contributes to fish kills and stresses in aquatic life. The city's stormwater management program goal is to restore and maintain the chemical, physical, and biological integrity of the Redwood and Minnesota rivers through pollution prevention and reduction. The city intends to continue to implement its stormwater management program to meet the requirements of the NPDES Phase 2 permit and its stormwater pollution prevention program. The City of Marshall's SWPP identifies the goals and best management practices, or BMPs, that will be implemented to meet the requirements of the Phase 2 rules. In doing so, the city will enhance aquatic and wildlife habitats and improve the urban environment to enhance the quality of life for its citizens. Beginning in the 1990s, the city started developing a surface water management planning process to integrate traditional planning for adequate infrastructure and water quality components. The result was the development of many ordinances which address stormwater management issues. So how do we accomplish the NPDES goals? Primarily through public education programs, informational flyers, and public outreach programs. We also recruit public participation in education and city cleanup programs, educate the public on illicit discharge detection and elimination. We work with developers, contractors, and homeowners on proper construction site management for stormwater control and quality. We promote programs for post-construction stormwater management in new development and redevelopment areas. Develop programs for municipal operations which prevent pollution and promote good housekeeping practices. We also develop a stormwater management page on the city's website to provide more information. The city will continue to review current ordinances and other regulatory mechanisms for the appropriate language and requirements with regard to erosion and sediment control practices. The city will adopt new ordinances or amend existing ones to address any deficiencies in the ordinances. For example, in December 2011, the city passed a new ordinance which addresses illicit connections or discharges. This particular ordinance establishes methods for controlling the introduction of pollutants into the MS4 in order to comply with the requirements of the NPDES permit process. The objectives of the ordinance are to regulate the contribution of pollutants to the MS4 by stormwater discharges, to prohibit illicit connections and discharges to the MS4, to establish legal authority to carry out inspections, monitoring, and enforcement to ensure compliance. So what impact does this all have on you, the property owners? We encourage you to incorporate best management practices into landscaping and other land disturbing activities, to prevent illicit discharges into stormwater, drainage ways, ponds, or rivers. Report observed illicit discharges to City Public Works staff. No dumping of grass clippings, leaves, or branches into drainage ways, ponds, or rivers. Do not blow grass clippings and leaves onto public streets or alleys. The voluntary use of phosphorus-free lawn fertilizers. Proper use of fertilizers, pesticides, etc. near drainage ways, ponds, and rivers. Proper disposal of household hazardous wastes. Prevent litter from trash cans or dumpsters. And ask City Public Works staff about stormwater issues if you have any questions. So what impact does this have on the developer or contractor? We ask that you implement BMP's best management practices to comply with the Phase 2 permit, conduct inspections to comply with the NPDES permit, maintain a separate daily diary or log with photo record and reports for erosion control management, develop project-specific erosion and sediment control plan, including implementation schedule, implement temporary best management practices for runoff control and erosion control, and this would include rock entrances to construction sites, erosion control blankets or stabilization mats, sediment basins, biorolls, sediment barriers like silt fence or silt curtains, check dams, and inlet protection. Implement permanent best management practices for runoff control and erosion control, and this may include riprapping of inlets and outlets, check dams, dikes, sediment basins or ponds, and turf establishment within a short period of time of disturbing the ground. Lastly, proper management of the construction site waste and debris, such as concrete truck washout materials, building waste, garbage, etc. Next, we'll go through some pictures of some good practices or good BMPs, and also some bad practices or maybe poor BMPs. It's kind of easier to get a visual of what some of the things we're talking about. In this particular example, this is a good BMP or a good example of seeding and mulching the site and having bioroll near the edge of the street to keep the material from washing out. The mulch helps hold the seed into the ground and keep that from washing away to get better turf establishment, and the bioroll keeps the material from washing away. Another good example of hydro seeding, which includes the seed and mulch together. This is on a city street project where the project, once complete, was hydro mulched. Here's an example of some bioroll being used near the riverbank, near a pedestrian bridge project. The bioroll is just on the top of the hill, so if a heavy rain event were to come along and materials would head down toward the river, it would be caught by the bioroll. Here's an example of maybe a poor situation where grass clippings are blown onto the street, and you can see the stormwater intake nearby. When a rain event comes along, those grass clippings will be washed right into the inlet and into the storm pipe and ultimately into the Redwood River. Here's a good example of a BMP, a good BMP example where there's bioroll used above a gabion project on the river. The bioroll keeps disturbed areas above the biorolls from washing away into the river. It's an example of inlet protection. You can see the inlet structure there surrounded by silt fence. The silt fence keeps materials from being washed into the inlet and into the storm sewer. Here's an example of a poor practice where dirt from a construction site is tracked onto the street, and you can see in the intersection and leading up to it all the dirt, and that'll end up in the storm sewer and into our river. Another poor management practice with gravel tracked from a driveway onto the street. A good hydro seeding example where you can see the vegetation starting to come up through the mulch. If you look in the gutter, there's also materials in the gutter that could probably be scooped out to make this a little better situation. Poor practice in this situation, the dirt stockpile material on the side of the road is up over the curb, and it's completely covering the flow line of the gutter. So when a rain event comes along, all that dirt will get washed into the storm sewer. A better practice would be to have that stockpile further back on the property with, say, a 10-foot grass buffer between the stockpile and the street. This would prevent the materials from being washed into the gutter. Here's an example of a bad practice for concrete washouts. You can see the white material on the ground. That's where a concrete truck washed their discharge chute onto the ground. Better practice would be to have that material contained and allowed to dry and disposed of as garbage. Another example of grass clippings on the street. You see all the grass clippings piled up in the concrete curb and gutter there. Here's an example of a house build that you look at after the fact, and it looks very nice. But prior to the site being complete, all this dirt was allowed to be tracked onto the road. Maybe that could have been prevented by having a construction entrance made of rock, so when vehicles pass through the property, some of that dirt gets knocked off the vehicle. And then if you do track on the streets, it's important that you sweep it up right away. Here's a bad practice of unprotected stockpiles of material. You see the boulevard is black dirt, it's all tilled up, and behind it's also a stockpile. There really should be some sort of protection at the back of the curb, like maybe a bioroll or a silt fence, or the boulevard area between the sidewalk and the back of the curb could have been left as grass, and that would have been an effective buffer to keep that material from washing onto the road. Another example of a fully tilled site. Unless you're going to seed the site within a week, there's no need to till the entire property. If you're going to be continuing to do work, it's best practice to maintain some grass strips on the property to filter that material if it were to wash away in a rain event. There's just an example of some looks like some soil or sand materials near the inlets. Here's a good example of seeding and mulching around a pond that was constructed in town. You can see the kind of the yellowish mulch material and some of the grass starting to come up. The mulch helps keep the seed and soil in place. Another example of seeding and mulching. Here's a bad practice where the city street and right-of-way is kind of used as a yard for storing materials. There's a stockpile gravel on the road, there's pallets being stored, there's a dumpster out in the road without a lid. A lot of bad practice here. Soil stockpiles should not be in the city streets. You should stockpile the material on the property that's being worked on and with some sort of protection around it. If there's not a grass buffer around it, then there should be a silt fence or a bio-roll around it. Other construction materials should be stored on the property as well. And here's in the same area, unprotected washout where a concrete truck washed out on the site. Like I mentioned earlier, that should be contained and disposed of at a later date once it dries up. More washout area across the road. You can see all the white material on the ground. Better view of the gravel pile on the street and all the dirt on the street. During a rain event, a lot of that material will wash into the storm sewer. And here's a zoomed in view of that dumpster with the lid open. When we know the wind blows in Marshall, and what will happen is all those construction materials will be blowing through the neighborhood. There should be a lid on all of the construction garbage containers. Here's an example of someone who mowed and blew the grass clippings towards the river, and you can see the riverbank is just covered with grass clippings. During a rain event, those clippings end up in the river, and they bring with it a lot of nutrients, which causes the algae growth, which is very hard on aquatic life. Another example on the river, you see a pile of leaves on the riverbank. Once again, that brings with it nutrients right into the river, and it causes a lot of harm. It's just a slide to show a panned out view of a development in town. You can see some good practice out there and some bad. You see some dirt in a gutter over by the excavator and a lot of unprotected disturbed soils, and then across the road you see some areas that are maybe seeded and good. Another example of good practice on a storm pond project with seeding and erosion control blankets on top to hold the seed down and hold everything in place. The blankets are very effective on steep slopes. That's all I've got today. If you have any questions about what we're doing with our stormwater pollution prevention program, you can give me a call. Jason Anderson, the Assistant City Engineer. The phone number is listed. It's 537-6773. Thank you for your time.